If a car was originally going 40 meters towards the east and took 5 seconds to turn and go 30 meters per second south, what is the acceleration of the car? So we actually start with this. We draw our car. It's going to the east at 40 meters per second. Then, over a time of 5 seconds, it turns, is now going south at 30 meters per second. Where time here is 5 seconds. Well, what do we know? We know our VI initial, so our velocity initial, in our x direction is positive 40 meters per second. We know our VI in our y direction is 0 meters per second. We know our VF in our x direction is 0 meters per second. We know our VF in our y direction is negative 30 meters per second. So we can actually I just broke those up into components. I used vector resolution to figure out what we're doing. So now we know our average acceleration equals our change in v over t. We know t equals 5 seconds. So when we plug this in, we can find our ax to equal 0 minus 40 meters per second over a time of 5 seconds. We can find our ay to equal negative 30 meters per second over 5 seconds. So we find our ax to be negative 8 meters per second squared. We find our ay to equal negative 6 meters per second squared. Now with that, we can actually just draw ourselves a triangle. I'm going to draw it over here on the right hand side so it fits. We're going to start here. Now we go negative 8 meters per second squared. Then we go down 6, negative 6 meters per second squared. What we're actually going to be finding is this resultant. So that's what we're going to look for. Now we can use Pythagorean theorem to figure that out. So we get, I'm just going to draw it up here in green, negative 8 meters per second squared plus negative 6 meters per second squared. We take the square root of this, and our final answer for our A, or our magnitude, not our direction yet, is going to be 64 plus 36, all under the square root, is going to give us 10. So our A so far is going to equal 10 meters per second. Now what's our direction? For our direction, I'm going to come down here and do our direction down here. So right now we have 10 meters per second squared at so-and-so degrees. How do we find our degrees? We have negative 6, we have a negative 8. We're looking for this theta. We know tangent of theta equals opposite over adjacent. So we can use that. Our opposite is negative 6 and our adjacent is negative 8. So we have negative 6 over negative 8 tangent inverse equals our theta. So our theta is going to equal 36.87 degrees. And if that's what it equals, that's our theta, that's going to be south of west. So our final answer for our acceleration is going to equal 10 meters per second squared at 36.87 degrees south of west. It's as simple as that for that question. There you go. Now I am going to move on to the next one, and I'm just going to skip all the way down to 12. And with 12, what is the acceleration of a ball that bounces off a wall in 0.3 seconds? If its incoming velocity is 60 and its outgoing velocity is 50 meters per second, find the acceleration. So we have our wall. I'm just going to draw my picture first. And the ball goes in at 60 and comes out at 50. And our time is 0.30 seconds. So I'm just going to break those into components. They're already in components, basically. So VI in our X, VI in our Y, VF in our X, and VF in our Y. So in our X direction, we have 60 meters per second, and then negative 50 meters per second. In our Y direction, we have 0 meters per second and 0 meters per second. Now we still use that same equation as before. A equals the change in V over T. So, by the way, change in V equals VF minus VI, just if we were forgetting what it meant. So, our VF, negative 50 meters per second, minus 60 meters per second. This divided by our 0.30 seconds equals our A, and that's just going to be negative 367 meters per second squared. And what direction is that in? Well, it started by going this way, so we classified that as east or positive, and it went in the negative direction. So I already have my direction on there by having negative, so I don't even need to put an angle on there. Now I can go down to 13 real fast too. So a car is traveling at 100 kilometers per hour due northwest. So I'm going to draw my car. It's traveling directly northwest. Here's our little coordinate axes. North, east, south, west. It's going at 100 kilometers per hour. Now, the driver puts on the brakes and turns 4 seconds later and is heading east. So now, going east at 50 kilometers per hour. This time that it takes is 4 seconds. So we have our picture, we see what we're doing. Now what we're going to do is we're going to find our VIX, VIY, VFX, and VFY. So we're finding all of these. To find our initial in our X direction, we have this angle right here is 45 degrees. So we can see that if we take our sine, we'll get our y. If we use cosine, we'll get our x. So cosine of 45 times, by the way, I'm going to take this right now, I'm going to change it to meters per second. It's going to make it a little bit easier numbers that we can refer to. So, oops. We take our numbers. We have 100 kilometers per hour. We have 3,600 seconds in 1 hour. And then there are 1,000 meters in 1 kilometer. And what do we get for that? We get 27.78 meters per second. So 27.78 meters per second. For our sine of 45 degrees gives us our y direction. That's how we figure out our y direction as well. Now our final velocity is just in the x direction. And we can see that in that x direction, it's going to be positive 50 kilometers per hour, which is also equal to 13.89 meters per second. And in our y direction, it's 0. By the way, if we look at our arrows, this should be in the negative direction, so make sure that this is negative, because cosine can be negative or positive based on where that was at. So now we take that same formula, we find our ax to equal, we find our ay to be, plugging them in there, we get cosine of 45 times that, we have our final velocity of 13.89 meters per second minus 19.642 meters per second. All this divided by 4 seconds. In our y direction, we have 0 minus 19.642. By the way, this should be negative. I'm just going to multiply that by -1 because it's in our negative direction, it's to the left, as we defined earlier. Divided by our 4 seconds. Now what do we get for ay and ax? Our ax is going to equal 8.38 meters per second. By the way, it's negative still. Dropped my negative on accident. Ay equals negative 'No, I was right. I did not drop my negative. I typed it in the calculator. Sorry. This will be positive, because if we're starting left and we're going right, we have to accelerate in the right direction. And our ay is going to be 4.91 meters per second. So we put those together. We can draw a little triangle. I'll draw my triangle over here. We have 8.38 meters per second squared. And then we have upward at 4.91 meters per second squared, giving us a resultant vector. Taking Pythagorean theorem, we get nine 0.715 meters per second squared. Now what angle is this at? Our angle, we're going to use that tangent inverse again to get .6 degrees. 30.36 degrees north of east. And there we go. That's how we figure out our problems.